Solving a system of equations by elimination is such a quick and efficient method for solving a system that sometimes we will go to great lengths in order to use elimination, even when maybe it seems like a different method would be better. In this case, we may look at this and think, well, there's no way we can do elimination here. Not only are none of the coefficients the same, but I don't even see a way where I could multiply one of the equations to make both of the equations the same. I mean, maybe multiplying by a fraction, but that would make things so much worse to have to deal with fractions. But if I look at the top equation, there's nothing I can multiply 4 by that's going to give me 3 so that the x's will match and vice versa. And same thing with the coefficients for the y. I can't multiply 2 by anything that's going to turn it into a 3. And likewise, there's nothing I can multiply a 3 by that's going to turn it into a 2. But we're not going to give up on elimination just yet. Elimination is such a good method that we're willing to multiply both equations by a number in order to still be able to use elimination, just because elimination is that good of a method. And what I mean by that is, although there's not a one-stop way to get our coefficients the same, if I multiplied the top by 3 and the bottom by 2, so if I multiplied the top equation, everything in it, of course, using the multiplication property by 3, and I multiplied everything in the bottom equation by 2, then my 2y would turn into a 6y, and the 3y would also turn into a 6y, and then I would have a 6y over 6y, and I could use elimination. So let's go ahead and do that. By the way, before I do this, I want to point out we could also do this with the x's. If I multiplied the top by 3 and the bottom by 4, then the x's would both be 12x, and I could do elimination. I'm choosing to do 3 and 2 just to keep the numbers lower, but we can absolutely eliminate the x's the same way. In fact, maybe we'll do that at the end to solve for x rather than using substitution, just to see what that looks like. So the top equation is going to be 12x plus 6y equals 24. That's what it looks like when everything is multiplied by 3. And on the bottom, we have 6x plus 6y equals 18. So coefficients for y's are the same, so we can go ahead and subtract these two equations. 12x minus 6x is, of course, 6x. 6y minus 6y is 0. And 24 minus 18 is 6. So we have 6x equals 6. The division property of equality naturally tells us that x is equal to 1. So there we go. We figured out what x is. So just for fun, we could take the x and plug it back into one of these now 4 equations that we've created. We could plug in x here. Let me actually put the line on the x. We could plug in the x here, or here, or here, or here, and solve for y. So we've got 4 different equations to pick from. But let's use elimination twice. Remember I said we could multiply the first equation by 3, which we've already done. And we could multiply that second equation by 4. So I want you to follow along with me on the second equation, that 3x plus 3y equals 9. We're going to take 3x plus 3y equals 9, and we're going to multiply everything in this equation by 4 so that the x's have the same coefficient. So 3x times 4 is 12x, 3y times 4 is 12y, and 9 times 4 is 36. And now our x's have the same coefficient, which means if we subtract these equations, the x's will eliminate, leaving us with just y's. So 12x minus 12x is 0. 6y minus 12y is negative 6y. And 24 minus 36 is a negative 12. And so the division property of equality gives us y equals 2. So we can actually solve, and this works for any elimination problem, just especially nice on this one, so we don't have to use substitution at all. Substitution with numbers like these will take longer than elimination, actually. But here we go. 1, 2, is the solution to this system, and we just used elimination twice. And if you're not convinced that it was worth it to do this work to solve using elimination, go back and solve this problem using substitution. Try to solve it from the beginning using substitution, meaning take the first equation, for example, and isolate the y, plug the y into the second equation to figure out what x is, and then substitute x in to find the value of y. Do all those steps and see if it doesn't take you longer than just doing elimination twice did. It is often worth it to do the extra multiplication on the system of equations so that we can use elimination completely as opposed to any other method. Elimination is that quick and that efficient that it's worth multiplying both equations by a number sometimes just so we can stick with that method.